We're going to be talking about services, web services in particular, but we're going to be talking about services without servers. So the gentleman to my right is Adam Hunter.
Hello, I'm Adam. I generally describe my programming career in terms of when I met Ben. I met him about 7 years ago now, and he taught me to program and has brought me up. We've been on and off working gigs together, and I am here today thanks to him.
Well, I appreciate that. Right, and this is me, Ben Vandgrift. Feel free to reach out on Twitter or email if you have follow-up questions or feedback or need to dispose of rotten fruit. And I think because I promised in the talk's description my cat, a rescue panther, that is Monster. He is a 20-pound, all lean muscle cat and likes to destroy my clothes. So, as Adam said, we worked together for a little while, off and on, sometimes like in the same job, sometimes just helping each other out, on the weekends. And until April of this year, I worked for Cognitect, and he persuaded me to come work with him at his company, which was more local to Charlotte, and that worked out well. It's a pretty common problem, though, that this company had, in that they didn't realize they were a software company. Everything that they did was dependent on their technology, all of their speed, all of the services that they delivered were delivered through the custom software that they'd built. But despite all of the pushing that we tried to do against the corporate culture, they refused to think of the software development team as anything other than the IT department. But that gave us a lot of free time because, when your stakeholders aren't invested, and when you can't get your feedback loop is on the order of weeks and you don't have any strategic direction, you start kind of fiddling around with the things that you're interested in and not the things that are currently on fire. And that has led to this talk. But one of the other things it's led to is Adam and I, along with one fantastically talented user experience architect named Melinda Jackson, founded a company called Aerostat. I'm not going to give a pitch for Aerostat, but if you like the logo and want to hear more, feel free to hit me up later. So we're going to be talking about change and change in technology and the particular serverless architecture that is becoming possible. But this is meaningful to me because I've had a ton of jobs. I've basically been working since I was old enough to walk behind a tractor. And regardless of the job, regardless of the product can be as good as you want, but it is the elements around the product, the things in the margins that are often the best candidates for improvement. So whether you're delivering pizza, the pizza delivery method is the best place to get improvement, better cars, better traffic, better tracking, 20 minutes or less or your money back. And while working through, finding new languages and working in different consultancies, I ended up at Cognitect, and this brought me to the world of Clojure, and I'm very fond of Clojure. I did write a book about it with our esteemed MC, Alex. But lately, it's not been a particular language. It's the whole thing, right? We have an idea, we move through the idea, we start to write code, we design an architecture, we deploy the code, we create systems around commits, hopefully that generate continuous integration and continuous deployment requests, but not everybody's comfortable with that. And then you have to put it somewhere, right? So where do you put it? And over the past few years, I guess, a common architectural pattern that we've been seeing in the industry is that of the service-oriented architecture.
You mean microservices?
Yes, I mean microservices. It's not a new idea, and everything that's old is new again. The term service-oriented architecture, I think, fell out of fashion about the same time that ivory tower architects became a thing that people sort of started sniffing at. But the beginnings of a service-oriented architecture started before there was infrastructure as a service. It started before you could have the degree of virtualization that we have easily available now. Servers on demand wasn't a thing. And so now microservices have kind of come into their own as something that's possible and relatively easy to do. So most of you probably know what microservices are. But in case you're not familiar, I'm going to have a little rundown here. They tend to be simple. They tend to be decoupled from the applications that they serve. They tend to be RESTful, which is good and bad, delivered over HTTP, chatty protocol. You know, we can have that debate at some other time. But they give you the ability to be scalable because the scalability of your microservices can scale at a different rate of the apps consuming them. And you can distribute the load of your entire application process over however many pieces you really want to play with. So they're handy. They give us the ability to compose our apps out of distributed components that we access via connections, what Martin Fowler called dumb pipes and smart endpoints. And I think that's pretty accurate. And if you've built a microservice, if you've, say, put one together to do data retrieval or anything like that, it looks about like this, generally. If you've got 20 minutes in OmniGraffle, you might put together something that looks like this. You've got an app, and inside of the app, you've got some kind of framework that's supporting the app, whether it's Pedestal or Rails or something as lightweight as Sinatra. You've got this routing piece that opens up your endpoint URLs on the internet. You've got a persistence piece in the back there that stores and retrieves your data, and a bunch of boilerplate code that you have to do because you have to do. And in the middle, you have these service functions. You can't see where I'm pointing with my mouse. You have the service functions there in purple. These are the meat and potatoes of the microservice. So you put these together, you put your app out there, and you send it somewhere, and you have a client. Say you've got a single-page application written in reagent, and you're talking to this application server. And this is pretty straightforward, right? Server, client, haha, we've been doing this for a long time. You might discover that you want to authenticate on some level. So you spin up an authentication microservice. And then when you make your queries to the app validates your token by calling the same microservice. And maybe you want to add an auditing piece. That's the little tail dangling down there. I probably should have labeled those. And then you build another app. So it needs another set of microservices. So you start getting more and more services. Then you end up with layers of services, services that compose other services. And before long, you run into something that's hard to categorize and hard to explain, and hard to visualize and hard to manage.
It doesn't look very micro.
It's not. But each of those little dots is very, very micro.
But it's turned into a gigantic monster.
It's turned into a huge thing. It turned into, in fact, it turned into that. So we're looking at we're looking at a system like this, and there's a bunch of complication that you can start to try to collect. So maybe instead of running a T2 micro instance for every single service, you spin up a Docker host and you build these things as containers, and you throw them in a Docker in a Docker host, or maybe you're using the Elastic Container Service. There's doing things like this costs a lot in terms of building your infrastructure in a particular way. When you consider that a microservice is supposed to be fairly stupid, and the network is supposed to be, I should say the microservice is supposed to be simple, and the network is supposed to be stupid, it doesn't matter what's at the other end of it. So you could be dealing with Java or Clojure, you could be dealing with Ruby, or it really could be anything. And then when you start to distribute this across a number of teams and your company's large, then it starts to get a little bit hard to manage. The other problem, of course, is money. And when you are deploying a bunch of servers willy-nilly, they can turn into lots of money. Your network is fronted by Cloudflare or something else to protect you from DDoS attacks, You have multiple layers of servers and like subnets full of RDS instances, and it's $10,000, $20,000, $30,000 a month, and it goes way, way up. And every 10,000 is, of course, another developer that you could have working on this problem. So it's costing you an operational expense in terms of the amount of money that you're actually spending on the services, and it's costing you an opportunity because the developers themselves are either not employed by you because you're spending that money elsewhere, or they're busy configuring and managing these systems. So when you get to a system of this size, you end up spending a lot of these, and my dad had a term for this, and he called it megabucks. You're spending megabucks, but you don't really need servers, right? Servers are just this thing that we don't need at all. We've gotten into a mindset, and it's been true for a really long time, and it's an easy thing to make because the words are so similar, server, services, that there's some correlation between these two things, and we want to take a service that we built and we want to deploy it on a server, right? It's got to go somewhere, right? Somewhere. But we paint ourselves into a corner. We have all of this stuff. And remember, every line of code's a liability, right? All of this is customized, configured, changed around. Your routing inside of there, the tasks that you have to deploy it, the project management in line. But we really care about these. And that's basically it. So why should we ever build anything other than these? So Rich and Stu are big on rationale, and I'd like to provide one. So there are a couple of reasons why this is important to me, and not just curiosity, but I really believe it's a direction that this industry can go. If we can abstract away all the detritus of the server, its configuration, networking, the framework, the other nonsense that we deal with from day to day, and just get to our service functions, we'd find a way to do that, then we can really focus on this one thing and not worry about the rest of it. And that's going to give us more time to make better, more robust, more scalable, more beautiful, and more functional service functions. It's also going to save us a bunch of money and time because we're only paying for the sections of code that's currently executing. If you're not running cycles on the CPU, why should you be billed for it? And finally, and I swear this is the only plea to your Mother Earth that I will make, these things cost a lot in terms of power. So if you want to be a good person and use less power, you should consider an alternative architecture. That's it, I'm done. I promise. Because services, it requires a different way of thinking. Is services are just functions. And the functions do one thing, and where have we heard that before? Right? They're not applications, they're not servers, they're just functions. And as we were building an application, it was a single page app. We said, why do we need servers? So we started trying to find a way around it, and we did. So before we go any further, I'd like to say a couple of things. The biggest one is we do not work for Amazon. Although we're recommending a bunch of their services right now. They do not give us a dime. And if Amazon, if you're listening, if you'd like to change that, please just start sending me checks. We do end up using a lot of their services, and I've been doing so for kind of a while. The next thing is, this is not necessarily something that's at present fully baked. I want to get out in front of it and get it in your mind so you can start to be thinking this way. I'm starting to try to use it a little bit in my practice and in our practice, and we've turned some clients onto it. But pieces of this architecture are brand spanking new, right? Like a couple of months old, and they haven't been worked on a lot. And their documentation, when it isn't wrong, it's thin and sometimes terrible. The deployment story isn't necessarily as well as we'd like these things to be. And I don't know what its upper or lower boundaries are, because I haven't had an opportunity to test it at scale. So with those things out of the way, I think the idea has legs, so I'm just going to plow through like it's something that's true. All right. This is the anatomy of a microservice call in its barest form. We get our widgets 32, we want format PNG back, and that constitutes a request. Right, that request gets pulled in by our app server or whatever we're wrapping this stuff in. Then we have this auth piece which says, oh, you have access to that or you don't. And then we have this little retrieve function that goes to our data store, looks up whatever it is, packages it in a response, and sends that back. This would be running on a server somewhere in the cloud or in a closet in the case of our old employer.
Had a lock.
It did have a lock. And we could accomplish all of these things with API Gateway, Lambda, DynamoDB, and Cognito. How familiar are you guys with these technologies? Like, really familiar, somewhat familiar? Okay, so, all right, I'm going to go through a little more detail then, just to make sure. So API Gateway is brand spanking new. It allows you to create endpoints, wire them up to things, and then transform the result that's coming out the back. You configure them, and then they're up, and you just go. You can do that across multiple different environments. You can have a staging environment, a production environment. You can deploy them using Swagger-ish. Sorta. Soon. It's gonna be better soon, I hope. And it runs about 350 per million calls. Right, not terrible. Then there's Lambda, which I think most of AWS reInvent this year was spent talking about to various degrees. There is a Lambda function, that is the service function I was talking about earlier. You execute this and then you return the result. You can push to it. It can poll, and you can have scheduled events. And this is billed by the 100 milliseconds of execution time. Limit of 60 seconds. If you go over 60 seconds, so like something's broke, you're done. But as long as you can finish your service function within 60 seconds, it'll just run, and you can keep throwing things at it, and it won't bother it at all. Piece number 3 is DynamoDB. Easy persistence for data with light relational needs. Yeah, I'm just reading from the slide, but that's the best phrase I could think of to talk about DynamoDB, and it's something that's bite-sized and consumable. It's really scalable. It's NoSQL-ish, but you can do a lot of the things you can do with SQL in terms of what you can query and all the ways that you query most frequently, but the more relational-ish you need it to be, the more you're kind of swimming against the current. So it works for quite a lot of use cases. And the pricing is extremely complicated. It's not extremely complicated. It's certainly more complicated than I want to get to in a slide.
It's pretty inexpensive, though.
It can be.
Yeah.
And Cognito, which I didn't know anything about until recently. Cognito was designed for mobile apps to allow you to sync mobile app data to the cloud. So it's built on the basis of syncs, so 15 cents for 10,000 syncs. But we don't care about that, actually. What we do care about is that it does a great job of providing identity and access management for insecure environments, like, say, an app running in a browser that somebody can just save the JavaScript and pilfer through. Cognito takes care of that. And in this scenario, you've of course got your usual storage and network costs that you're going to get hit with by Amazon regardless. So here's our backbone, and now we're going to plug in the pieces that are relevant to removing servers entirely. So we can configure API Gateway with a GET request to widgets with an ID and a format, ship that off to a Lambda invocation, which will contact Cognito to do our authentication, retrieves the widget from DynamoDB, returns the result to API Gateway, which formats it to JSON or XML or whatever we specify, and kicks it back out the door. And we've done all this without actually booting up a single server ourselves. There's just nothing there. So I know you guys want some examples. Examples?
Examples.
Okay.
So we're going to switch over to GitHub and the browser to give you guys a couple of pieces to walk through. First, let me apologize for my voice. I've had a cold for about a week. Not quite sure why. I assume it's Ben's fault. We have a reagent application that is very sparsely styled, so please feel free to heckle it as you like. Excuse me. The application is going to contact mostly API Gateway to be able to run whatever types of code that you need to run on the server, and then get the results back, process them, and you can have a lot of your view logic, and I'll even talk about putting some of your business logic in the browser. So we have put this up on GitHub. Obviously, we have 4, if you will, services that are living in here. Each one of these is their own application. The actual application itself lives on S3. So normally I would be sitting up here behind the microphone thinking, man, I'm getting billed every single second while my demo's up and running on EC2. But in this particular case, because I only get billed when people use it, I don't care. So I can take up all your time and not be charged any money. No. So I'm going to do a little bit of demonstrating, and I'm going to hop into the Amazon console. How familiar with the Amazon console are you guys? Pretty familiar? Okay, so I won't spend a huge chunk of time in there. If I need to bump up the font sizes, please let me know, but I'm going to go ahead. All right. So, oops, wrong button. Bring this up a little bit. So I'm going to refresh this guy. I literally just ran CLJS build once and then ran S3 to upload, so it's not optimized for production, so on and so forth, and it complains about Figwheel not being attached. But this is the reagent app that's going to talk to the different microservices.
We did have a much more beautiful application to demo, and then I left the company that owned the app. So this has been put together reasonably last minute. Moose once bit my sister.
Hastily. So the first thing we're going to talk about is the unauthenticated portion, so we can solve maybe 10% of the business use cases in the world. But this piece is pretty straightforward. I'm literally I wanted to grab the EC2 prices, but you would not believe how some expletive that Amazon has around actually fetching those prices. The Lambda prices are very easy to get, and I just scraped them off their webpage. So I grab them, transform them into a basic JavaScript object in here. You can see I've got these 2 fancy execute API, US East, Amazon, AWS, staging, pricing, EC2, and Lambda calls in here. And the first thing I want to talk about with API Gateway is it gives you a lot of flexibility in what you're trying to do. So the premise is, yes, there are, technically speaking, from our point of view, no servers, but Amazon is obviously running servers, and the computing paradigm that we're all familiar with pretty much lives on. They have, as far as I can tell, a API Gateway set of clusters that runs Nginx and a bunch of different transformation rules. It goes in 4 steps. And each step can be customized for how you want to handle it, so it can transform the received request before it actually hands it off to what it's going to do with that. And then it has the ability to actually send that to someplace else and then transform that request. So you have the ability to customize at all 4 stages. In this particular example, I'm going to hop over into our API Gateway. And you can see we have, let me make this a little bigger. Maybe you can't see. We have our user session pricing, and the pricing has EC2 and Lambda underneath it. Now, one of the things that's very, very, very half-baked from Amazon is the ability to automatically deploy or automate your deployments to API Gateway. As far as I know, I may be the only person on the planet who has gone through the trouble of using their Amazon Labs, Swagger, Java jar, importer tool utility in their pet store example to figure it out. So I do have a pretty solid working example for you guys on there, which I'll show you in a second. The premise here, so like I said, Lambda was pretty easy to get, so I need to be able to get the pricing by fetching the actual page from Amazon that has the prices on it and doing some DOM manipulation to get some numbers out of it. That is entirely written in a Clojure script function. Actually, let me pause here for a second. How many of you guys do more Clojure script than Clojure? Okay, so not a ton of you guys. How many of you guys are doing Clojure script running on Node? Awesome. Okay, so a lot of this stuff is going to be right up your alley, and everyone who's not, you should start. the big reason that I'm using mostly Clojure script on Lambda instead of Clojure is because the JVM boot up time is very, very high. So the example that we had was originally a PDF generation service that we wrote in Java. And we didn't really care if it took 3 seconds or 6 seconds or whatever, because it was doing a lot of work, generating PNGs and all that kind of fanciness and Java interrupt, fandom heck.
So as a slight aside, if you're doing very infrequent invocations, then Node has a better startup time. If you're keeping the thing busy quite a lot, then the JVM comes up to speed and stays up to speed, and you get very good performance out of the JVM.
We did some back-of-the-napkin calculations by causing Lambda to write things into S3 so I could see how many different endpoint or clusters they were coming from, and I got about 4 in the US region. Everything inside of Amazon, also as an aside, actually talks to itself using Cognito. Which is also the most horribly and error-prone documented piece of software I've probably ever seen. So if you get anything out of this, it's a functioning example with Cognito in the browser. Anyway, so the difference between Lambda and EC2 is that Lambda runs a Lambda function to get the Lambda prices. I apologize for using the same words for everything, but I do it all the time. And the EC2 one works a little bit differently. This is some super excellent style sheets they've got going on here. There we go. So let me hop into here. So in this particular case, the integration request, you generally have 3 options when it comes to API Gateway. You can either have it be a mock request, which means that it can just serve you up some random static data that you've already uploaded to API Gateway via its transform mechanisms, and I'll show you guys that in a sec. You can have invoke pretty much any Amazon service you want to. So you can say, Amazon service X that I have control over, I would like to wire you up to an HTTP endpoint that I can just call and have it do stuff. In this case, Lambda is an excellent candidate for that. So now I have a nice fancy URL that I can run and get the response of my Lambda function. And that solves most of my how do I not use the server use case. Getting the actual EC2 pricing, though, that's actually in a JavaScript file with a JSON-P callback that has like 15,000 levels of nesting. So I scrapped that entire thing once I finally got it downloaded. But what you can see here is it does type HTTP. And the reason is, how many of you guys are using cores? Some of you guys, yeah, it's generally pretty horrible as far as developing with it and often makes me cry. Sometimes Ben will console me. Sometimes he tells me not to use cores. So what I needed to do is I could normally just fetch this file with JavaScript or on the server side or whatever, but I needed to be able to fetch this arbitrary JavaScript file via reagent on some other domain. It doesn't have cores header, so I'm pretty much boned. In this case, I was able to put an HTTP pass-through in API Gateway, so it will do the fetch for me on the quote-unquote server side, add the cores headers I need, and give me back what I have, problem solved. So that's phase 1, fetching data. We have Lambda function to fetch some data, HTTP proxy, if you will, via API Gateway to fetch some data, and we have some fancy-looking endpoints. But like I said, that's maybe 10% of business use cases without being authenticated. So what we really wanted to do is give you guys a working example of how to wire together reagent with Lambda, API Gateway, and Cognito, and DynamoDB so that you guys can have a user system. The first thing I'll point out is you don't have to use DynamoDB. We're just using it because it's way easier. And there's a JavaScript client for it. There's not really a great way to work with RDS unless you're... I have never, ever tried to do that in Node. And my Clojure code's pretty weak. But you could very, very easily boot up a Lambda function that's running Clojure or Clojure script and have it talk to your RDS instances if you've configured your security groups properly. So we're using DynamoDB because it's easy and this demo is hasty, but don't think RDS is out of the question. So when I have my sign up here, I can just put in some random information and it's supposed to be, let's do 99 because I have no idea how many times I've done this before testing. And it's a little bit slow because it's running through my phone's internet. Creates an entry in DynamoDB, which we can go see very quickly. This, yeah, there we go, 99, something like that. So this is what we just inserted into DynamoDB. I sent a request via the CLJS Ajax to API Gateway, who invoked a Lambda function on my behalf. That Lambda function contacts Cognito to get an identity, and then inserts that into the database. This password is I ran it through bcrypt because that's what I'm told you're supposed to do, and I figured I would at least be able to look you in the face and say I pretended to make it secure. But one of the caveats I ran into, and it's an aside that you all may run into, is when you are if you're using Node, for instance, because you need the lower latency boot times on your Lambda functions, you can't have any Node libraries that have to be compiled. I'm certainly not aware of a way to get them compiled onto whatever machines they're actually running on. So my first bcrypt wrote out a couple of object files, and I deployed that, and the error message I got back was bad elf, and I assumed it had something to do with Christmas, but I really had no idea. So I switched to a JavaScript-only implementation, got it up and running, worked fine. So I'm going to hop over to sign-in, which I've got over here. All kinds of crazy fun stuff in here. Let me clear that out. So where the first part, that makes sense. It's an unauthenticated screen. I'm just capturing some data. I'm running some code. There's a couple of pitfalls you may run into. But now I'm going to go ahead and sign in where it really gets kind of useful. This will take a second again, too, because it's going through here. You can see it ran through API Gateway, and I have this giant token sitting up here, which is my OpenID 2 token. So I have... Has anyone here used Cognito? No, maybe one guy? For JavaScript or mobile apps? Nothing. Okay, mobile apps. That's what I figured. So most of the stack, if you look, looks like you're making a mobile app, dude. What are you doing here talking about web pages? And that's mostly because it is shaped almost exactly like a mobile app, and you're downloading it and then just trying. You don't want servers, right? So everyone using your program probably has a computer at home, and you don't have to pay for them to use their computer. So that puts us in the position where we want to try and offload as much of our logic into the actual application as we can. And Amazon's JavaScript API client is actually really fantastic. I've got a couple of examples up here to show you. So when I create a new Amazon DynamoDB object, I can call getItem. I'm going to get an error when I do this because, A, it's an arbitrary table. But there's two things about the error I want to point out to you guys. So I get bad request. Awesome. A, that table doesn't exist, but if we look down here, I have my Cognito serverless auth role, blah, 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 is not able to perform this action. So what I've done is I've inserted a record into DynamoDB. I sync that record with Cognito, which gives me a fancy Cognito ID. Then I can make a call to Lambda, which has the longest function name I've ever seen, which is get developer token for OpenID 2 and a bunch of other words. And that gives me this token over here, and that token I can use in the JavaScript app itself to begin to request. So I don't have to have a server at all. I can talk right to DynamoDB, pardon my hand movement, right to DynamoDB, right in JavaScript. I mean, I'm literally doing it in the console on some random S3 bucket, and if I had created the proper IAM roles, Cognito has what I like to call superpowers in IAM. So you get this fancy ARN, if you will, and you can do all kinds of fun wildcards and splats inside of your IAM policy. So you can say, Cognito users may be able to write to this DynamoDB table, but when they do that, they're only allowed to access keys that start with their user role, or their user ID that comes in through here. And the only way they can get that user ID is by logging in through the Amazon's credentials and running that Lambda function to get you the token first. But that lets you build all kinds of applications without ever touching a server, and you have all of the authentication you need. You can do the same thing for S3, where you can prefix buckets or keys inside of buckets to access them entirely in JavaScript. I can tell you it's kind of a pain in the neck to pull down PDFs via AJAX and that type of thing, but it's not the end of the world. You can also do, let's say that you have a Clojure function, for instance, that A, takes a long time to run, and B, it only does things for users who are authenticated. You can say only Cognito authenticated users can run this Lambda function. You don't even have to hook it up to API Gateway. A, there's a Clojure script library, which is great for invoking Lambda functions, and B, we can just run it via the Amazon client if we so chose without having to touch any sort of servers whatsoever.
You promised me you wouldn't be talking this fast.
Yes, that's true. I lied, though. I was tricking him. So I'm going to hop into Cognito for a second just to kind of show you guys what is happening in the system as I walk through. So I can see I've created 10 identities this month. This guy, my identity browser, I can see all of the people I'm using. Now, they're not keeping the password for me. They're not keeping my user's email or anything like that. That's all stored right over in here in DynamoDB. I just use this private ID that they assign to me in order to link up these two systems so that I can begin to use my roles to be able to allow my Cognito IAM people to do whatever they need to without even touching a server. And you can see I've got a couple of these guys in here. It's very, very well fleshed out, Cognito. If you're using mobile phones, the documentation is excellent. The JavaScript documentation is so bad that I was telling Ben I was thankful that the first time I ran into a problem that I remembered the Stack Overflow Google search I did to actually find the right documentation. That or go to our repo. Unfortunately, not unfortunately, and fortunately for you guys, it's all in Clojure script, so it should be pretty easy to parse through. And I'd rather see it in that certainly than raw JavaScript. So last piece, I'm going to hop into Lambda and talk a little bit about that. So one of the two things about both Lambda and API Gateway, if you're pretty familiar with the Amazon console, when you go to do an EC2 instance, there's like maybe 6 buttons you can click. Launch the thing and then get out, use SSH, do whatever you need to do. It's not a whole lot of tuning or tweaking or any kind of interaction, and that's pretty much the same for a lot of Amazon services. If you need any kind of advanced mode toggling, you have to use their CLI clients or whatever or their API to be able to do what you want. In Lambda and API Gateway, they have what are essentially WYSIWYGs for getting you started because their API exists, but their clients suck. In fact, there is no client published by Amazon for API Gateway yet, which seems almost psychotic for them, seeing as what they're trying to do. However, I was able to find on the deep dark corners of the interwebs on Amazon Labs GitHub profile a prototype client that will allow me to do some work. So let's talk about...
This is why we don't work for Amazon.
Yeah, right? I'm sure they would not let me tell you that. So let's pop over into some code. I want to show you some deployment stuff, and then I'm going to hand this back off to Ben, and we can take questions. So in my API repo here, or my API folder I have in here, I don't really have much in here but bin. And this is the AWS import. So they have both a jar file that acts as the client and a jar file that acts as the importer. How many of you guys have used Swagger? So, okay, excellent. So everyone's pretty familiar-ish with Swagger. I had no idea what Swagger was until I had heard of it, but I mean, I just assumed people were talking about me. And then I found their Swagger importer, and I was like, well, what's Swagger? Let me figure this out. Because if there's one thing that Ben taught me by repeatedly bashing me over the head was automate everything. So my deploy scripts are pretty straightforward. I just have a bunch of bash scripts. I can run bin deploy, and it'll automatically sync up this pretty heinous looking YAML file and create everything I need inside of API Gateway. But if you look at this, there are a couple of nice things about it. One, if you're let's say that you're building your services, you have sort of a dev team who's working on your actual Lambda functions or code or whatever you're actually having them do that's important and hard to do, and then you have a front-end team that's going to consume them. If you're linking them via API Gateway, you can run this to the Swagger editor and say, go look at the documentation yourself. I don't have to tell you how this works. And the documentation that comes out of it's actually really fantastic. Ben will be the first person to tell you I won't write docs unless I have a tool to write them for me. So, swinging down here a little bit, I was trying to find this section in here. So you can see this is the fancy Amazon API Gateway integration that is extended onto Swagger. In this case, the type of integration is AWS. This is the very, very, very long ARN for invoking Lambda functions via API Gateway. One of the downsides to this file you can see here is also smattered with cores, headers everywhere. And that's, at the moment, the nature of the beast. But it does allow me to actually write all of my API Gateway in in a text file and then deploy it, which means I can automate that process and I can have check-ins and tests and so on and so forth around that process without clicking all of the buttons in API Gateway's interface. This really fancy thing up here essentially is entirely there just to add options checks because, pre-flight's the best. And they're in the actual interface, there's literally a button that you click. It's like, do you want to turn on cores for this? We're going to make all these changes for you. So again, I'm not quite sure why they've moved away from the ability to automate things into more of a it's just a fancy Angular app, which doesn't even always work on Chrome, FYI. Sometimes you have to use Safari. And this is it. So I've got a bash script that goes through, parses this whole file, uploads it, and that goes from there. Hopping into the other couple of things, talking about deployment. I have never shipped a production ClojureScript app, so first thing I should tell you, when you look at how I'm shipping the reagent application, is be embarrassed for me. So pretty much, I just compile, I run clj build once, and then I just use the S3 command to ship a bunch of things into an S3 bucket and make sure everyone can read them. And it's pretty straightforward, and it works okay. I have found a lot of success, though, writing my deployment scripts in Bash. I may be writing them in something like Ruby or Clojure in library form, but it ultimately gets invoked in Bash, and every system that I've tried to integrate with, for the most part, runs Bash. So hopping back out of this, talking about deployments, we also have this fancy pricing thing. So when I first started making ClojureScript on Node to run Lambda, I had no idea that there's a really, really awesome CLJS Lambda line again plugin. So I didn't use it, and I did this team hard way. And you can see I've got even more bash scripts because I'm doing it team hard way. And this guy's insane. And actually using this to deploy multiple functions spirals out of control very, very, very quickly. I'll show you guys the code real quick just so you guys can get an idea of how simple it is, though. This ClojureScript code is probably pretty terrible, but I'm using request in Cheerio because trying to run requests in Node using HTTP always makes me sad. But the general gist of it is grab the document, grab the stuff out of it, send it off to this handler. The documentation around Lambda and integrating with it's pretty good compared to API Gateway or Cognito. Well, Cognito's pretty crap, but this gets much, much easier if we let somebody do most of the work for us. So when I hop into SSO, which is the thing handling our registration and token generation, you can see I've got a project.clj. I have clearly forgotten to push on here for some reason, or it didn't work or something. I have a bunch of code in here which connects to DynamoDB, grabs my Cognito identity, so on and so forth. So this is a little bit more heavy-handed. Right now I've been using the main function and running Node to test these things. You can see very, very sexy, very, very robust testing solution down here. But the nice part about this is it handles the Node module creation for you automatically by using export, and it has a bunch of very handy wrappers. So I have wrap Lambda function, which I can use, so I can send everything when you're running in ClojureScript and Node is asynchronous, so it does a very good job of trying to make sure you're not 45 callbacks in before your response needs to happen. The other nice thing about it is I think the key driver behind Lambda from Amazon's point of view is asynchronicity. So like just fire and forget, and something will happen later, or you'll generate an S3 item which can kick off another Lambda function and notify you through WebSockets or however you want to architect it. But I'm lazy and I'm used to the normal computing paradigm, so I just made these things return for me immediately, especially because it's way harder to show you guys a demo otherwise. So usually what you would want to, when we're talking about this, obviously, when my end user is clicking sign in, I need that function to return. So I've structured it in a way that to do that. However, what I should probably do next is call this send email Lambda function, which can return immediately, and then have it connect to SES and send me an email and do all that kind of fun stuff. And the same thing for every S letter something that Amazon has. You can wire them all in here, or you can wire them into API Gateway. I mean, the possibilities are literally almost endless. So if you want to build an application where it sends you the email in the browser by connecting to API Gateway, which triggers an SES email, you can. Although if I download it, I'm going to write a Chrome extension to stop it from sending me an email. I think that pretty much wraps us up through here. I would go into the Prezzo reagent app, but you guys are welcome to do that in private and have a good laugh. At this point, I'm going to hand it back over to Ben.
All right. Now I'm confused. There we go.
Huzzah.
All right, so how many slides do I need to skip now to get us out soon? Okay. I'm going to sort of skip to the end. Good. Our original target for this was a single-page reagent application hosted entirely in S3. But once we get into things, there are a number of other obvious targets for this type of architecture. Infrequently called microservices seem pretty obvious. Something only gets hit 2 times a minute. Why are you paying for the rest of the minute? Services with limited usage patterns. A lot of our clients were 8 to 5, and that's it. Offloadable CPU-intensive computation. So currently, the CPU is scaled by the amount of memory that you give to the Lambda function, but I'm told that that will change. You'll be able to scale the memory and CPU independently. So you're still limited to 60 seconds.
Yes.
But, that could be useful because you can run it as many times as you need. Scalability is not really an option. Not really something you have to mess with, except for each individual Lambda function has its own constraints. And then for unpredictable loads, it would also be a fairly good solution. So the advantages of this, getting back to the sort of architectural side, are going to seem really familiar. Each function is simple. Because you don't really worry about the scalability and distributed nature of it, you have a lot of power at your disposal, and the power grows as you need it to without really you interfering at all. And
One of the things as far as Lambda goes is there's no auto scaling or anything like that. Amazon handles, I don't know if this thing's on.
Yeah.
Amazon handles pretty much all of that for you, right? So you don't worry about auto scaling, you don't worry about load balancers. If you have 15 million Lambda requests, you're going to end up paying, 15 times $3.50. And that's it. It'll just work.
That's one of those things we haven't tested the upper limit on, but that's what the interesting documentation says. We've never had a problem with it. It's never even flinched. And the ability to abstract away all of these things into Lambda functions gives us a certain amount of focus. Simplicity, power, and focus should sound really familiar to you, and as these are some of the values that are inherent in Clojure itself. So, not fully baked. You've been warned, and your mileage may vary. But this is a new landscape. It's sort of an initial flag down in what I expect to be sort of a broader trend. It's not too many years ago, we didn't have on-demand servers and virtualization and infrastructure as a service, and now we do. Serverless microservices weren't possible a year ago. Easily possible a year ago, but they are now. So the landscape is changing, and it just kind of requires us to adapt to it. So hopefully at the end of it, we'll be able to focus more on the service functions itself, and that gives us more useful resource usage and less resource waste. So if you have questions, we can take a few. If you